Okay, let's get right into it. Welcome to this explainer where we're stepping into the role of your exam turnaround coach. Today, we're taking a messy, average approach to Cambridge AS and A-level computer science, specifically syllabus 9618, and completely rebuilding it into a perfect mark strategy. We are zooming in on 1.1 data representation, looking at binary magnitudes and prefixes. Now listen up, because this is definitely not just about memorizing a few technical terms or prefixes. No way. It's about mastering the exact step-by-step methodology examiners are practically begging to see on your paper. Look at this quote for a second. The difference between a B and an A star in computer science often comes down to how well you understand 1.1 data representation. I mean, wow, that comes straight from a senior examiner, and it completely sets the stakes for us today. Mastering this specific topic isn't just a nice to have. It's literally your direct ticket to an A star. It's the absolute foundation that your entire coding, hardware, and analytical framework relies on. If this foundation is shaky, the whole house comes down. So, how do we get you to that top tier? Here's our game plan. First, mastering core binary principles. Second, the method mark strategy. Third, the top 3 examiner warnings. And finally, winning critical analysis marks. Let's jump right in. Section 1. Mastering core binary principles. Right, let's start by defining something absolutely crucial: analytical depth. In the Cambridge Assessment Framework, this means prioritizing logical, structured reasoning over what we call superficial breadth. So, what does that actually mean for you? Well, it means examiners are absolutely not looking for isolated, rote-learned facts. They don't just want a data dump. They demand precise definitions, clear causal relationships, and the logical reasoning behind exactly why a specific binary magnitude is being used in a given scenario. Think of it like a 3-piece puzzle. There are 3 distinct cognitive domains that the assessment objectives target when it comes to binary magnitudes. First, knowledge and understanding. Second, application. And third, analysis. You see, you can't just define what a MIBbyte is and call it a day. You have to be able to apply that concept to a real-world scenario and then analyze its efficiency within a specific computer system. It's all connected. And here is a massive, game-changing insight straight from the principal examiner reports. They highlight that candidates referencing cross-topic connections achieve significantly higher marks, period. So never, ever view binary prefixes in isolation. It's a huge trap. Integrating this knowledge with other areas of the syllabus, things like hardware memory architecture or network transmission speeds, is exactly the secret recipe top candidates use to stand out from the crowd.
Section 2. The method mark strategy.
Okay, we really need to address the elephant in the room here. Why on earth do students find multi-step calculations and method marks so incredibly hard? It's a critical question. And honestly, the answer lies in understanding the strict procedural framework required for algorithmic thinking. Too many candidates panic, rush to write down a final number, and completely bypass the structured process that the examiner is actually grading. They're basically throwing points away. If you want to secure every single possible method mark, you have to follow a strict procedural framework. It's a 4-step process. 1. Design your algorithms. 2. Implement your solutions. 3. Test thoroughly. And 4. Evaluate performance. Showing the examiner you're working, proving that you are moving logically through these 4 steps, is exactly what guarantees those vital intermediate marks, even if your final calculation happens to be slightly off. Digging a little deeper, algorithmic thinking actually demands that you break down those multi-step calculations using a very specific mental checklist. You absolutely must demonstrate step-by-step decomposition, you need to select the appropriate data structures, show efficient code implementation, and prove rigorous testing. Let me be clear. If you skip decomposition and try to do an entire binary calculation in your head, you are self-sabotaging. Write it out. This really sums up the whole issue. On one side, we have superficial breadth. This is your average candidate's approach, usually just a messy, jumbled pile of numbers with zero explanation. It's a failing recipe. On the other side, we have analytical depth. This is the top-scoring candidate's structured reasoning. The average approach completely ignores methodology and hopes for the best, whereas analytical depth guarantees maximum marks because it proves exactly how you arrived at your answer. Section 3, top 3 examiner warnings. But hey, quick pause. If you want to stop serving up average grades and unlock the secret recipe for an A-star, subscribe to Ace the Exams right now and hit that notification bell. All right, let's get back to the breakdown. So going back to the data from the principal examiner reports, we found 3 devastating mistakes that candidates make time and time again. These will instantly forfeit high tariff marks. Warning number 1, using the wrong formula or algorithm for the context. A classic example is confusing base 10 prefixes like kilo and mega with base 2 prefixes like kibi and mibi. Huge mistake. Warning number 2, forgetting to check boundary conditions and edge cases. And warning number 3, giving generic, copy-paste answers that aren't specific to the context of the question being asked. And please pay very close attention to this one. It's a massive examiner alert. Candidates consistently confuse key terminology. You must always define your terms before using them. This is a trap so many students fall into. Think about it. If you don't define your terms in an extended response, your subsequent calculations completely lose their contextual foundation. The examiner needs to know that you know exactly which units and prefixes you are working with before you start crunching numbers.
Section 4, winning critical analysis marks.
When an exam question asks you to compare different approaches to data representation, you're doing comparative analysis. That means you have to explicitly connect both similarities and differences. And the trick here is using proper comparative connectives. You should be using words like however, conversely, or similarly. And here's the kicker. You have to back up every single claim with supported numerical evidence from your binary calculations. You can't just state a difference, you have to prove it.
This right here is your absolute gold standard checklist for evaluating alternatives and justifying your recommendations to the examiner. First, you have top scoring evaluative thinking. This means you're actively considering multiple solutions, you're analyzing the trade-offs of each, acknowledging their limitations, and fully justifying your decisions. You pair that with the second column, flawless data interpretation. That means correctly extracting info from binary representations, performing the math accurately, and drawing rock-solid evidence-based conclusions.
Now, exams are stressful, and it's easy to blank out under pressure. So we've got a fantastic memory hack for you to lock this all in. Just remember the acronym DATE. D stands for decompose steps. A is for analyze trade-offs. T is for test edge cases. And E is for evaluate alternatives. Whenever you're stuck on a high-mark data representation question, just think of a DATE. It'll instantly help you recall exactly what factors you need to cover to get full marks. So, bringing it all together, the final question I have for you is, are you ready to actually apply this analytical depth to your next past paper? You now have the exact playbook to avoid those common examiner traps, structure your working, and score maximum method marks. Next time you face a complex binary prefix question, are you going to settle for superficial breadth, or are you going to step up and command the analytical depth of an A-star candidate? I know which one I'd choose. Before you go practice those past papers, remember to subscribe to Ace the Exams, turn on those notifications, and comment down below with the subject and level you're currently finding the hardest. Keep studying smart, and I'll catch you in the next explainer.